All right. A couple more theorems are going to be very useful for us. The base angles theorem says if two sides of a triangle are congruent, isosceles, then the angles opposite them are congruent. So I would suggest you get in the habit of drawing these arrows to remind yourself that the opposite ones, and then mark them congruent like so. All right? And the converse of that is if you have two angles that are congruent, that was a mistake. That should have been an eraser. Let's try this again. If we go this way, we can mark these equal to each other. Okay? So it's a really nice, useful thing to know. Now, it's a little bit challenging when we look at this, but if you think about it, this is the same thing as this. All right? It's just turned. So here's D, here's F, here's E. So it's a little easier, I think, for most people when they look at it this way, but it's the same thing. We know that this angle and this angle are going to be equal to each other. So angle F is congruent to angle E. Okay? Because of the base theorem. All right, copy and complete the statement. If HG is congruent to HK, so let's mark that. HG is congruent to HK. That means this angle here and this angle here are equal. But we cannot say angle G is equal to angle K. And the reason we can't say that is because K has more than one angle there. So we need to say GKH to specify that we're talking about this angle here, because there's too many angles at K. So you have to be careful about that. We could also call it HKG. Doesn't matter which order you go in. All right? So that's nice to know. Then it says if angle KHJ, where's that? KHJ, that's up here, is congruent to KJH, well, then if we draw our lines here, like so, we know this side is equal to this side. So HK and KJ. Okay? Easy peasy. All right, so corollary to the base angles theorem. If the triangle is equilateral, then it's equiangular because we can do this, but we can also do this. And then if it's equiangular, it's equilateral. So if you know you have a 60-60-60 triangle, it's equilateral. If you know it's equilateral, it's a 60-60-60, which leads right into this problem right here. Since these sides are all equal, that means it's equiangular. These are all equal also, so that means 60 degrees each. Pretty simple stuff. And then over here, since we know all the angles are equal, that means it's also messing up. That means it's also equilateral. So that means each side measures 5. No big deal. Pretty simple stuff. All right, last example. Find the value of x and y in the diagram. Okay, well, y is an easy one because if you notice, this triangle here is equiangular, which means it's also equilateral, so y is 4. All right? But that also means that this is 4 right here. Okay? Now, let's go one step further. We know that these angles down here are equal, which means these sides are equal. That means x plus 1 is equal to 4. So now, by subtraction, x is 3. How about that? And then your exit ticket, you're going to do on your own. We'll talk about it in class. In the lifeguard tower, PS and Q is equal to QR. Okay. Help us be able to see S. There we go. All right. So you can mark on there. And QPS is equal to PQR. Explain how to prove QPS is congruent to PQR using what we know.